All right, today we're going to talk about logarithmic functions. So let's talk about a logarithmic function. It is the inverse of an exponential function. So as long as x is greater than 0 and b is greater than 0 and b is also not 1, then y equals log base b of x if and only if b to the y power equals x. So if you think about it, if we talk about inverse functions, if I give you a function y equals a to the x power, well, to find the inverse, we would switch x and y, and then we're stuck. We can't take the y-th root. We have to figure out something else. That's where logarithms come in. So we take our base becomes the base of the logarithm. To solve this, we write log. Base stays the same, so in my case I'd use an a, of x. A logarithm is the opposite of an exponent. So let's rewrite these as logarithms. So I start with the base of my exponent. The base is 10, so I do a log with a base of 10 of this number over here. What did it equal? 10,000. Equals the exponent. Some people like to draw a little swirly here. Whatever. This means 10 to the 4th power equals 10,000. For the second one, we do log. The base is the same, so it's 1/8. Of, well, what did it equal? It equaled 64. Equals the exponent, which is -2. Something that I cannot stress enough to you. A logarithm equals the exponent. So log base 6 of 1 equals 0. Let's rewrite that as an exponent. Well, the base of my exponent is the base of the logarithm, which is 6. The power is 0, and it equals 1. The second one, the base of my logarithm is 9, so the base of my exponent is 9. The power is 1/2, and it equals 3. Remember that a 1/2 power is a square root, and the square root of 9 is indeed 3. Now let's evaluate without a calculator. So this first one, log base 2 of 32. Basically I'm saying 2 to what power gives me 32? Well, 2 to the 5th power makes 32, so the answer is 5. Log base 3 of 27. 3 to what power gives me 27? Well, that's 3 cubed, so the answer is 3. Log base 4 of 2. 4 to what power gives me 2? Well, the square root of 4 is 2. Square root is a 1/2 power. 4 to the 1/2 power gives me 2. A few more. Log base 10 of 1/10. So really I'm wondering 10 to what power gives me 1/10? Well, that must be a negative first power, so my answer is -1. Log base 3 of 1. 3 to what power gives me 1? Well, to get 1, it's the 0 power, so the answer is 0. Log base 2 of 2. 2 to what power gives me 2? Well, that's the first power. The answer is 1. Now, this part says use a calculator. We haven't actually talked about how to use a calculator on this yet, so we are going to circle back to that in a little bit. Basic properties of logarithms. As long as x is greater than 0 and b is greater than 0 and also not 1, and there's any real number y, doesn't matter what it is, log base b of 1 is always 0. Every single time. Doesn't matter the base, log base b of 1 is always 0 because anything to the 0 power gives you 1. Log base b of b is always 1 because anything to the first power is itself. There we go. Log base b of b to the y power is y because base power b to the y power is b to the y power. And b to the log base b of x power will give you x because, remember, I'd rewrite it as a logarithm with this base of this value. Well, that is already what it says in the exponent. So let's simplify these. I have log base 4 of 1. 4 to what power gives me 1? Well, that's 0. There's my answer, 0. Log base square root of 7 of square root of 7. So I'm saying the square root of 7 to what power gives me the square root of 7? Well, it's the first power, so the answer is 1. Log base 36 of 6. 36 to what power gives me 6? Well, the square root of 36 is 6, so that's a 1/2 power. All right, now we're going to do a little solving, because this works the exact same way. The log base 3 of x is log base 3 of 12. Well, the only way that can work is if x is 12. Done. Log of 2x plus 1 equals log of 3x. We'll talk about what that means in a second. Those two inside parts must be the same, so 2x plus 1 must equal 3x. Subtract my 2x over. I get x equals 1. There we go. And log base 4 of x squared minus 6 equals log base 4 of 10. As long as these logarithms have the same base, we are good to go. Just set the inside parts equal. Add my 6 over. X squared equals 16. So x must equal positive or negative 4. There we have it. There are two special types of logarithms, because in your calculator, you'll notice you don't have log base something. A logarithm with a base of 10 is called a common logarithm. It's very useful because our base 10 number system, the metric system, scientific notation, and the fact that that's what your calculator has. On your calculator, it just says log. That is a base of 10. So y equals log of x if and only if 10 to the y power equals x. Log without a base written in is the 10th base. And then we have logarithms with a base of e. We call those natural logarithms. They're used in many branches of math and science, especially with compounding interest. So y equals ln. ln is natural log. I think of it as log natural. If and only if e to the y power equals x. Natural log is really just a log base e. All right, that's what it is. We never write this, but that's what it is. So that brings me back to our problems from before where we were going to use a calculator. A log with a base of 10 is the ones we can do in our calculator. So log base 10 of 10, all I do is hit this key that says log. It pops up log, type in a 10, boom, oh look, it's 1. 2 times log base 10 of 2.5. Well, this one I needed 2 times log 2.5. Close my parentheses if I want, 0.796. And log base 10 of negative 2. I will take log of negative 2. Uh-oh, error. We'll say this is undefined. Because if you think about it, 10 to what power would give you negative 2? Nothing. There's no power of 10 that gives you a negative value. It doesn't work out. Can't take a logarithm of a negative. So let's do these few without a calculator. Log of 100. Remember, that's a log base 10. So we're saying 10 to what power gives you 100? Well, that's the second power. There we go. Log of the 5th root of 10. So we're really saying 10 to what power gives me the 5th root of 10? Well, a 5th root is a 1/5 power, so our answer is 1/5. And log of 1/1000th, that's 10 to what power would give me 1/1000th? Well, 10 to the 3rd power gives me 1,000. So to make it a fraction, it's -3 as our final answer. 10 to the log of 6. Remember, that is 10 to the log base 10 of 6. An exponent and a log with the same base cancel each other out, leaving me just 6. ln, remember natural log, log base e, of the square root of e. Remember that a square root is really a 1/2 power. A log and an exponent with the same base cancel each other out, leaving me just that exponent, which is a 1/2. ln of e to the 5th power. Well, my log and my exponent have the same base, which means they cancel, leaving me just 5. E to the power of ln of 4. Exponent and logarithm with the same base, they cancel, leaving me just what was inside the logarithm, which is 4. Let's use a calculator to evaluate these, and then we'll check by the exponent. Log of 0.43. I get negative 0.3665. We'll say it's negative 0.367 since we're rounding to the nearest thousand. To check the corresponding exponential, we'll go 10 to the power of negative 0.367. I get 0.4295, pretty darn close to 0.43. It's off a little because I rounded my answer. Log of negative 3. All right, log of negative 3. Error. You cannot plug a negative into any logarithm. It'll be undefined because 10 to no power whatsoever would ever give me a negative. ln of 23.5. You may notice you have an ln key as well. ln right here, the one we've hit second to get e. So ln of 23.5, 3.157. To double check that, we'll do e to the 3.157, and we get very darn close to 23.5. ln of negative 5, type that one in. Uh-oh, error again. ln works just like all the other logarithms. Can't plug a negative in. Now we're going to solve some equations by turning them into exponents first. Log base 2 of x. That means our base is 2, the exponent is 5, equals what's inside the logarithm of x. Well, we know what 2 to the 5th power. 2, 4, 8, 16, 32. Oh, look. X is 32. Done. Log of x equals negative 2. That means the base was 10. The power was negative 2 equal to x. Well, 10 to the negative 2nd power is 1 over 100. And look at that. We have our solution. ln of x equals 3. To solve this one, we turn it into exponential. Our base here is e. The power would be 3 equals x. I need a calculator for that one, simply because we don't know how to evaluate e without a calculator, at least not easily. So x is about 20.086. Make that 2 a little better, my decimal a little better there. Now let's talk graphs. If our base is between 0 and 1, so your base is a fraction or decimal, right? Your function is decreasing. The limit as x approaches 0 is infinity, and the limit as x approaches infinity is negative infinity. So the graph should look something like that. It approaches infinity when you get close to 0. It's going down forever on the right. Notice that we have an asymptote at x equals 0. An exponential function had an asymptote at y equals 0. They're inverses. If my base is bigger than 1, then your function's increasing. And this one's kind of wonky. As x approaches 0, we approach negative infinity, so down. And it looks something like that. X equals 0 is still a vertical asymptote. The domain is always the set of positive real numbers, so that's 0 to infinity. The range is all real numbers, negative to positive infinity, and we pass through the point 1, 0. Every exponential function passes through 0, 1. Every logarithmic function passes through 1, 0. So we're just going to talk about what the graph of this would look like. G of x equals log of x minus 1. Just like our other transformations, we have a subtraction in with the x. That means it is a shift right by 1. So that means instead of passing through the point 1, 0, we would pass through 2, 0. And our asymptote, instead of being x equals 0, would be x equals 1. Other than that, it's looking very darn similar. And our base is 10, so it's increasing. Sorry. All right. 2 plus log base 10 of x. Well, that 2 plus means we shift it. It's a positive 2, so we shift up by 2. So instead of passing through 1, 0, we pass through 1, 2. Other than that, everything else is pretty much the same. For our domains, remember that the domain is usually 0 to infinity. So what does that mean if I shift my function 2 to the right? Well, if I shift it 2 to the right, instead of getting really close to 0, I'm going to get really close to 2. But I can still go up to infinity. ln of 2 minus x. Let's think about, factor out a negative. I get x minus 2. I shifted right 2, but I also reflect over the y-axis. So that means instead of being 0 to infinity, it's actually negative infinity to 0, and shifted 2 to the right, negative infinity to 2. And ln of x squared. Well, I have to keep positives inside of my logarithm. When I square something, it'll always be positive. But I cannot take the ln of 0. So really just x squared can't be 0, which means x can't be 0. So our domain is anything but 0. And if you want to see a couple of these graphs, let's look at ln of 2 minus x. There we go. Notice that is an asymptote. Remember, we have to be smarter than our graph. Oh, ln of x squared. It's just got a little hole there. All right, and an example for us. We have some students participating in a psychological experiment, and they attended several lectures on a subject. At the end of the last lecture, and every month for the next year, they were tested to see how much of the material they remembered. The average scores in the group were given by the human memory model, where T is time in months, and here's the equation for it. What was the average score on the original exam? So if we plug in T equals 0, f of 0, 75 minus 6 ln of 0 plus 1. Now I could obviously plug this in a calculator, but we can also do it by hand. ln of 0 plus 1 is ln of 0. Any log of 0, any log of 1, losing my mind here, sorry. 75 minus 6 ln of 1. Well, any log of 1, e to what power gives you 1? 0. 6 times 0 is 0, which means f of 0 is 75. Their average score was 75 on the original test. At the end of 2 months, we're just going to find f of 2. 75 minus 6 ln of 2 plus 1. Well, I can't do that in my head anymore, so let's find out. 75 minus 6 ln of 3, 68.408. Not too bad for 2 months since that. And the average score after 6 months, we were looking for f of 6. Use my calculator again. 75 minus 6 ln of 7 this time. It's about 63.325. Not going down super fast, right? And that's kind of how logarithms work. As time goes on, they slow down. All right, you're going to have an assignment on logarithms now.